Good morning. This is the start of the lecture videos in Math 21, and the first lecture video is on the limit of a function and limit theorems. When we speak of a function, we have a relation of two variables. You have x, and you also have the dependent variable y. If you fix a value for x, then you get a fixed value for y. However, if x ranges across a set of values, then the effect on y is that y will also have a set of values, and we want to determine if this set of values is moving towards a particular value, which we will eventually call as the limit of the function. So given a function f of x and a real number a, so what this means is A is an element of the set of real numbers. What is the value of f at x near A, or but not equal to A? So we say that uh, we say that x approaches A, but x is not necessarily at A. So let's consider this illustration. So we have f of x equals 3x minus 1. We can assign values to x near 1 and observe the behavior of f of x. So suppose we take values less than 1. So if x is 0, f of 0 will be 3 times 0 minus 1 is just negative 1. If x is 0.5, you get 3 times 0.5 is 1.5 minus 1 is zero point 0.5. If x is 0.9, you get 1.7, and so on. If x is a 0.9999, you get 1.99997. And you can establish a pattern that the more nines you have on the left side, then the right side will also have more nines in it. Okay, so the question now is, as your x is approaching 1, what value will this approach? Okay. Now, suppose we try another set. So x is greater than 1. So we can start with 2. So 3 times 2 is 6, minus 1 is 5. When x is 1.5, that's 3.5, 1.1, 2.3. Here, the more zeros we put after the decimal point, we are also putting more zeros on the function value. So this is approaching 1 also. This is approaching what value? Okay. So from the illustration, it should be obvious. So as x gets closer and closer to 1, f of x gets closer and closer to 2. Okay, so that is what we observe here. All right. So graphically, this is what happens. So if you see this, this if you see this value here, so when x is at this point, your y is here, and then as your x goes to 1, this value is here, and then when it is at 1, almost 1, the value is almost 2. So the graph is going up as your x is going to the right. Now, on the other hand, if you take values of x greater than 1, This is what happens. So now you have when x is greater than 1, your y is here. And when x is approaching 1 in this direction, your y is going in this direction. Okay? So eventually, when x is at 1, we can say that your function value is approaching 2 along this line. Okay? So f of x gets closer and closer to 2. Now let's have another example. Suppose we have g of x equals this rational expression. Now, is this defined for all values of x, or do we have a limit? So by now you should know that there's a restriction on the domain, on the possible values of x. And if you factor the numerator, so by the way, what we can say here is that this is true provided that x is not equal to 1. Because when x is equal to 1, the denominator becomes 0 and the whole thing becomes undefined. But when we factor the numerator, this is what we get. And from here, we can see that we can cancel the x minus 1, provided that x is not equal to 1. Okay? And this is just the same function that we had earlier. Use f of x. So, graphically, ano naman yung nangyayari sa kanya? So, at x is equal to 1, g of x is not defined. So, that means we have here a hole. Okay, so there's a hole at this point here. And when you use values of x near 1, it's the same thing. So your values from greater than 1 goes down to 2. Your x, when x is less than 1, your y values goes up to 2. Okay, so again, we say that g of x gets closer and closer to 2. Now let's have a third example. So let's consider this. So here, this is just like the original f of x. When x is not equal to 1, so there's a hole when x equals 1. However, when x is equal to 1, we assign a value, 0, to it. So graphically, this is what happens. So the first line here, 3x minus 1, x not equal to 1, this is the entire line that we have, okay? And then you have the hole there. However, when x is equal to 1, the value of h of x is 0. So there's the point. You see the point there? So it's like you have a point at y equals 2 and it dropped to 1. So the function value at h of x is 0. But what is the function value of h as x approaches 1? So again, we can use our grids and we can see that it still approaches 2. Okay, so these three examples illustrate that you can have different functions approaching the same value, and the graph of these functions are almost the same except for some finite number of points. Okay, so then we would say that the limit of those functions as x approaches 1 is equal to 2. So the idea here is if you have a real number a and a real number L, and f is defined on some open interval containing a except possibly at a, so meaning baka at a may denominator nito 0 siya, then the limit of f of x as x approaches a is L if the values of f becomes closer and closer to L as x assumes values closer and closer to a but not really reaching a. Okay, so palapit siya na palapit kay a pero hindi kailangang nasa A talaga siya. So, limit na yun. No? The notation that we use is this. So, the limit, so we read this as the limit of f of x as x approaches a equals L. So going back to our examples, the first example, f of x equals 3x minus 1, we say that the limit of 3x minus 1 as x approaches 1 is 2. Okay. Another example, note that in this case, the limit is equal to the function value itself. Meaning, if you evaluate f of 1, so f of 1 is equal to 3 times 1 minus 1. This is equal to 2, which is the same as the limit. So the limit equals its function value because the function is defined at x equals 1. Now, how about this example? The limit here is 2 because your function values approaches 2. Okay. However, g of 1 is undefined, okay, because g of 1 will become 3 minus 4 plus 1 divided by 1 minus 1. And this is 0 over 0, which is undefined, which is not a number. Okay, so 0 over 0 is undefined. A good question is, what is the definition of undefined? So yun yung pag-isipan ninyo. So the limit exists, but the function is undefined there. Okay. Now for the third example, the function h, this is what we have. So again, the limit of h is 2. So because then you will just be using this function. However, the function value at 1, what is h of 1? H of 1 is 0, as you defined here. When x is equal to 1, your function value is 0. So h of 1 is 0, not equal to the limit of h of x as x approaches 1. So in finding the limit of f of x, this is what we usually do. First, you try, you only consider values of x very close to a, but not exactly at a. So the limit of x is not necessarily the same as f of a. That's the simplistic idea. No? You just compute f of a and that's the limit. That is not always true, as we have seen in previous examples. And then you should let x approach a from both sides. When we say from both sides, if this is the value of a, then you should choose values of x coming from the left side or less than a, and coming from the right side or greater than a. And so from the left side, x is less than a. From the right side, x is greater than a. So only then can you say what the limit is. Now later we will have one-sided limits and see that there are functions where the limit coming from the left is different from the limit coming from the right. Now, if f of x does not approach any particular real number as x approaches a, then we say the limit of f of x does not exist, or we simply write d and e, does not exist. For example, consider the Heaviside function, which is an important function in, for example, imaging. So when x is positive or non-negatively valued, the value of h is 1. If x is negative, the value of h is 0. This is the graph, okay, of the Heaviside function. Now, the question is, what is the limit of h of x as x approaches 0? Okay, that's the question. Well, if you come from the left side, you approach the value 0. When you come from the right side, you approach the value 1. Okay, so what we say here is, Is the limit 0? The answer is no, because it's different from the right side. Is the limit 1? Again, the answer is no, because it's not the same value from the left side. So we conclude here that the limit of h of x does not exist. Okay? So we have this theorem. If the limit of f exists, then that limit is unique. You cannot have two limits for a function. So that is not possible. The only time you may think of two limits is in the following illustration. Let's say you have this graph and your function is, your x is approaching this value. And then you may say that, sir, it is approaching this limit and that limit, L1, L2. So as x approaches A, then your function is approaching L1 and L2. But this is not a function. Okay? Why is it not a function? This is not a function. Now, the requirement is we must evaluate the limit of a function. And thus, the limit of a function, if it exists, is unique. Now, what is the limit of a constant number? The limit of c. So as x approaches a, c is constant. It is not changing. So it remains c. Graphically, y is equal to c as the graph of a horizontal line. Okay, so this is y equals c. So whatever x value is coming from the left or from the right, the value will always be c. Now, what is the limit of x as x approaches a? So if x is approaching a, then your function f of x equals x will also be approaching a. Okay? Kasi x is approaching a, so the limit of x will also be a. So parang pinalitan mo lang siya ng value. Right? Additional theorem. Suppose that we have two functions, f and g. The limit of a function f is L1 and the limit of a function g is L2 as x approaches a. Suppose c is a real number and n is a natural number. So yung n na ito, yung natural numbers, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The positive integers. The limit of a sum or difference of the functions f equals the sum or difference of the limits. Okay, so the limit of a sum is the sum of the limits. The limit of a difference is the difference of the limits. Okay? If I have a product, the limit of a product is the product of the limits. Okay? If you have a real number, we call it a scalar, times a function, the limit of a real number times the function is the real number times the limit of the function. So it appears that the c can come out of the limit expression. So the c times L. The limit of a quotient, provided that the limit of g of x is not equal to 0 as x approaches a, is the quotient of the limits. Okay? Provided L2 is not equal to 0. L2 is the limit of g of x. Okay? So with this, parang ang dali-dali lang mag-evaluate pala ng limit. No? So pag may mga terms ka, the limit of an expression with several terms, you just get the limit of each term. And you get the combined values. The limit of a power, so f of x raised to n, is equal to the power of the limits. Okay? L sub 1 to n. So for example, let's evaluate this limit. So you have here a quadratic, a polynomial, 2x squared plus 3x minus 4. So what is the limit of this? So we can make use of the fact that the limit of a sum is the sum of limits. So we have a sum here and a difference there. So we can write this as the limit of 2x squared as x approaches negative 1 plus the limit of 3x as x approaches negative 1 minus the limit of 4 as x approaches negative 1. Here you have a real number multiplied to x squared. So, pwede nating ilabas si 2. So, magiging 2 times the limit of x squared as x approaches negative 1. Here we can put out 3, the limit of x as x approaches negative 1. The limit of a constant is constant, as we have said. The limit of c is c. Then we can get the limit of a power is the power of the limit. So the limit of x as x approaches negative 1 squared plus 3. The limit of x as x approaches negative 1 is negative 1. So you just replace the x by negative 1 minus 4. So this is 2 times, now this is negative 1, the limit of x as x approaches negative 1. This is minus 3 minus 4. So 2 times negative 1 is positive 1. So this is just 2 minus 7 equals negative 5. So the limit of this is negative. Okay. So let's see the solution. Okay. Now, in general, if you have a polynomial function f of x, the limit of f of x as x approaches a always exists. And it is equal to, natin, parang ito. If you look at this expression here, it is but the polynomial evaluated at negative 1. Diba? So if you have a polynomial f of x and you get the limit, you just replace the x by a, evaluate it, and that will be the limit of your polynomial as your x approaches a. Another example. What is the limit as x approaches negative 2? Okay, so here we have a quotient. So the limit of a quotient is the quotient of limits. So this is what we first have. Okay, the limit of a quotient is the quotient of limits. And then sa numerator, you just have a polynomial. I hope you're familiar with what a polynomial is. No? So ano nga yung mga polynomials natin? They are of the form a n x n plus a n minus 1, x n minus 1, plus and so on, plus a sub 2 x squared plus a sub 1 x plus a sub 0. Okay, so where n is a natural number. So yan yung mga polynomials. So the numerator is taking the limit of the polynomial. The denominator is a polynomial also. So easily, you just replace the x by negative 2 cubed, negative 2. So you have plus 3, negative 2 squared, minus negative 2 plus 1 all over negative 2 squared plus 2. Okay? And you simplify things, and the result is the following. Negative 17 over negative 17 over 6. Okay, so let me clear that. Okay. So that's the limit of this rational expression. Now, if you look at this expression, this is a rational function. So what is a rational function? A rational function is a quotient of a polynomial or of two polynomials. A polynomial over polynomial. So that makes it a rational function. Polynomial over polynomial. If f is a rational function and f of a is defined, no? So meaning denominator is not equal to 0 at that point, then the limit is again simply the function value, no? At that value of x, or at x equals a. Okay. Now let's consider radicals. So square root, cube root, nth roots. Suppose that the limit of f exists and n is a natural number. Then the limit of the nth root of f of x as x approaches a is equal to the nth root of the limit of f of x as x approaches a. So the limit of a radical is the radical of a limit, provided that when n is even, so square root, fourth root, the radicand, so what's inside is called the radicand. The radicand must be non-negative. Okay? So the limit of that, I mean the limit of that must be greater than 0. Kasi alam mo, square root. Hindi ka pwede magkaroon ng square root of -1 or -3. Kailangan positively valued yan. No? So that's the requirement. So for example, what is the limit of the square root of 3x minus 1? So firstly, you have to, so the limit of the square root is square root of the limit. So when you evaluate 3x minus 1, this is just a polynomial. So that will be 3 times 3 minus 1. So that is 8, and 8 is greater than 0. So fine. Okay. So the answer is just the square root of 8, or 2 square root of 2. How about this one? The cube root, the limit of the cube root. So the limit of the cube root is the cube root of the limit, okay, of a rational function. So the numerator is polynomial, denominator is polynomial. So what you can do is replace the x by -1, hoping that the denominator does not become 0. Okay? So just replace the x by -1. And the denominator is not 0. So it's just -3. So 3 over -3, the cube root of -1 is -1. Okay? And one more example. How about this? The limit of the fourth root of 3 minus 2x. So we try to evaluate the fourth root of the limit. So what is the fourth root of the limit of 3 minus 2x as x approaches 7x? Okay, so that becomes the fourth root of the limit of 3 minus 2 times 7 halves, and that is equal to the fourth root of 3 minus 7, which is -4. So this one is less than 0. So this is imaginary, not a real number. So hence, the limit is always an element of the set of real numbers. So then we conclude that this limit does not exist. Okay. All right. Another example here, evaluate this power. So the limit of a power is the power of the limit. So this is now a mix. No? So you have a power here, you have a radical there, then you have a rational here, a polynomial, okay? And when x is equal to 3, it is good to immediately check the denominator. So what is 3 cubed minus 3 plus 4? So that is 27 minus 3 is 24 plus 4 is 28. So, okay naman. Hindi naman siya 0. So, we can continue. Okay, so the limit of a power is the power of the limit. The limit of a quotient is the quotient of the limits. So, and then apply natin yung radical and then theta, no? So, sa numerator, madali na lang yan. That's 18. 2 times 3 times 3 squared. Minus yung inside the radical, you get 15 plus 1. So, that is, this one is 16. Positively valued naman siya. So, you can get the square root of that. It's 4. Denominator is just a 28 cube. So then this is 18 minus 4 is 14 over 28, which is the same as 1/2. Cube is 1 over 8. Now, this is our example earlier. We have shown that the limit of g of x is equal to 2. Although g of x, g of 1 is undefined. No? Undefined. Now, let's try to compute the limit. So take note that the limit of the numerator is 0 because when you replace the x by 1, you get 3 times 1 minus 4 times 1 plus 1, and this is equal to 3 minus 4 plus 1 equals 0. The denominator will also be 0. Okay, so 1 minus 1 is 0. So the limit appears to be 0 over 0. Appears to be 0 over 0. But what is this? But take note, when x is not equal to 1, so we're saying that x is only approaching 1 but not equal to 1. X is only approaching 1. So since hindi pa naman siya equal sa 1, when we factor, we can cancel the x minus 1 and evaluate the limit now of simply 3x minus 1. Okay? So this limit is the same as the limit of 3 times x minus 1. Because x is not yet equal to 1, so we can still cancel. Okay? And this is just a polynomial. Evaluate, place the x by 1, you get 3 times 1 minus 1 is 2. And that's what we have shown earlier using the graphing method. And we got it analytically. X is equal, the limit is equal to 2. Okay. Now, whenever we encounter a limit equals the form 0 over 0, we say that this limit, the limit is an indeterminate form of type 0 over 0. It is not, you don't say that the quotient is indeterminate. What we say is the limit is indeterminate. Okay? If you have a quotient which is 0 over 0, that is undefined. So 0 over 0 is undefined. However, the limit that is equal to 0 over 0 is indeterminate. Okay? It's indeterminate. So the limit is indeterminate, but if you have a quotient, 0 over 0, that's undefined. And there will be other forms, indeterminate forms that we will encounter later on. So how do we handle indeterminate forms? So this is what I was saying earlier. This is undefined. The limit above may or may not exist. So to evaluate, we can do factoring. We already had an example earlier. If it involves radicals, we can do rationalization of the radical that goes to 0. For example, if you replace the numerator by -1, what do we get? You get a 1 minus 2 plus 1, 0. Replace the denominator by -1, you get 0 also. So this limit is indeterminate. Pag nag-zero yung numerator class or yung ilalim, polynomial yan. If you remember the factor theorem, do you remember the factor theorem? So if P of X is a polynomial and P of A is 0, then X minus A is a factor of the polynomial P of X. Okay? So that's the factor theorem. If P of X is a polynomial and P of A gives you 0, by the way, P of A is the remainder when you divide the polynomial by X minus A. So that's the remainder theorem. If P of A becomes 0, so the remainder becomes 0, then X minus A is a factor of the polynomial. So since the numerator here becomes equal to 0, the denominator becomes equal to 0, then we can automatically say that this is the same as the limit of X minus minus 1. So what is X minus minus 1? This is equal to X plus 1, okay? This is X plus 1. So factor, X minus A. So X plus 1. And then you just need to determine ano yung other factor ng numerator mo. So X pa rin ito, 1 pa rin ito. This is in fact a perfect square trinomial. So X plus 1 over X plus 1. And then denominator is X plus 1. X approaches negative 1. Only approaching but not yet equal to negative 1. So hindi pa siya 0. Yung X plus 1 is not yet 0. So we can cancel the X plus 1. So you just evaluate now the limit of X plus 1 as X approaches negative 1. And that is just negative 1 plus 1, which is 0. So the limit of this is 0. Okay? So I will clear and show the solution. Another example. If you replace the numerator by negative 2, you will get negative 8 plus 8, 0. And denominator, you will get a 4 minus 4 is 0. This is a polynomial. This is a polynomial. So meaning you can, this is of the indeterminate form na 0 over 0. So to evaluate this, we can factor. So the limit of x cubed plus 8 is the same as x plus 2. So that is for the x minus minus 2. So I hope you remember how to factor the sum of 2 cubes. So if you have x cubed plus a cubed, so you get x plus a, x squared minus xa plus a squared. Okay. So this will be x plus 2, x squared minus 2x plus 2 squared, or that is 4. Okay, so tingnan natin. Okay, so tama. Okay. And then, yung denominator natin, pag minus pala to class, this is minus, and then this is a plus sa ilalim. So ito yung mga magpe-pair. And then this is always plus in the last one. All over. Denominator is just the difference of 2 squares. So ano yung factor ng difference of 2 squares? X squared minus a squared. This is x minus a, x plus a. So x squared minus 4 is x minus the square root of 4, which is 2, times x plus 2 as x approaches negative 2. We can cancel the x plus 2, and you just get the limit now of x squared minus 2x plus 4 over x minus 2 as x approaches -2. So this is rational, so you can replace the x by -2, -2 squared. So this is -2 squared. My pen got lost battery. 2 squared minus 2 times -2 plus 4 all over -2 minus 2. And what do we get? This is 4 plus 4. 8 plus 4 is 12 over -4. And that is equal to minus 3. Okay. So, tignan natin yung solution. So, this is what we have. -3. Okay. Another example. So, when x is equal to 4, what we get here is 4 squared minus 16, that's the numerator, and that is equal to 0. Whereas in the denominator, what we get is, here we get 2 minus the square root of 4. And 2 minus square root of 4 is 2 minus 2, which is also 0. So this is also an indeterminate form. Okay, so it is just 0 over 0. So how do we deal with this? So take note that in the numerator, since it is a polynomial, the numerator can be factored immediately since nag-zero yung ating, so it becomes x minus 4 and x plus 4. Okay? All over. Now, yung denominator natin nag-zero then. Now, to solve this, we multiply with what is called the conjugate. So, it's just a difference of 2 squares. Now, 2 minus square root of x, para mawala yung square root na yan, i-multiply mo siya ng 2 plus the square root of x. Now, both numerator and denominator, so in effect, you're just multiplying by 1. Okay? As x is approaching 4. So, ito yun, no? Here. Okay. And then, yung numerator mo will become a difference of 2 squares. So you get 2 squared minus the square root of x squared. The square root of x squared is just x. So you will get 4 minus x. Okay? And then yung numerator, pwede mo i-factor as we have shown earlier. This becomes x minus 4x plus 4, 2 plus square root of x. Can we factor? Can we cancel anything here? The answer is yes, no? Because yung x minus 4, yung x minus 4, type here on the side, the x minus 4 is the same as the negative of the quantity 4 minus x. Okay? So that means this expression here and that expression here are cancelable. And when you divide by x minus 4 both, sorry, this is not negative 4 minus x. This, yeah, this is correct. No? So when you divide by 4 minus x both sides, so this will just cancel. Okay, so this will cancel. And this is equal to negative 1. Okay. So that is what happens here. So this will cancel. And you just have a negative 1 for this. So there's the negative. Okay, so here's the negative here, negative 1. And then the rest you just replace by the value of 4. So you replace x by 4. Okay, and you get 4 plus 4 is 8. Square root of 4 is 2. 2 plus 2 is 4. 8 times 4 is 32. And then you have a negative, so it's negative 32. So that's the limit. Okay. And another example. So how about this one? This is a cube root. So you just use the difference of two cubes. So earlier I gave you the formula for that. So take note that the numerator becomes 0. The denominator also becomes 0. So when you rationalize, so here we are rationalizing the numerator. Rationalize the numerator so that the radical is removed, and you can factor and possibly hopefully cancel with what's in the denominator. So you will multiply this by the cube root of x squared plus 2, the cube root of x, plus 4. Okay, the cube root of x squared plus 2, cube root of x, plus 4. And same with the denominator. So the numerator will become the cube root of x cubed, or that is simply x, minus 2 cubed, which is 4. And which is 8. So you get x minus 8. Denominator, yung x squared minus this x squared minus 7x minus 8, dahil nagsi-0 din siya, factor niya si x minus 8. So mag-a-appear yung x minus 8 in the denominator. There you go. X plus 1, and then you just rewrite the entire radical expression. Put them in parentheses, okay? And then the x minus 8 will cancel. And so you are left with this expression, and then you just replace the x by 8. And this is what we get. Okay? All right, so this completes the first lecture for the first lecture for Math 21. Okay, and I hope that you do the exercises. So some additional exercises you can look into this exercise and find the limit of this polynomial. Okay, so that is all for